Hello, everyone. It's Mike Merker here with People Solving Impossible Puzzles. It's episode 37. I'm joined by Alex. Alex, tell us all about yourself. What's up?
Oh, I'm here to catch up with my friend Mike after a few years and see what we've been working on. Last few we met each other pretty randomly and hit it off right away. And I'm gonna guess because we're both creative and we like to build things. And we I remember we met and we instantly hit it off. Like we talked for hours. I think we walked for hours. We drove around and we discussed like different aspirations that we had in the future, and things obviously probably changed, and that's the through this time. And I'm generally curious to know from that time what you've been working on and what's changed from that period, and what I've obviously from that point. I think that was like maybe 10 years ago. Um, on my side, a lot of things have changed on my side. I've been obviously working on a lot of different things, but back then it was trying to remember what we were doing. It was a lot of programming for sure. Uh, I can't remember really what I think you were starting to program back then, or you had aspirations to program back then. Uh, and what was tell me.
Yeah, yeah,
What
yeah.
was going on?
The tables have turned. I'm being interviewed here. I have to be careful. So I guess for a long time, I always thought about just reaching for a bunch of props here. I always thought about like the Hebrew alphabet,
Right, right.
and I was like, hey, that's really complicated.
It
And
is.
then I thought about all the different. I took courses a long time ago in mathematics, a lot of university math courses, and a lot of linguistics courses. I was always very interested in like Chinese characters, Japanese alphabet, Korean alphabet, all the different languages, all the different alphabets. And I was like, how come there isn't just like one alphabet that's
Like a
just like
universal alphabet.
easier? Yeah. That was, I think, the original thought. And I mean, going way back, what to like, when did we first hang out? 10 years ago?
Yeah,
Okay.
yeah, yeah.
So, yeah, oh man, I was probably, I don't know, what was I like? I'm probably, like, I'm married, I
Oh
have
man,
five kids
I
right
can
now.
tell you. Yeah, yeah. You still you were. I think you were still married back then, or you were just married, or you were getting married. I remember you had a woman in your life for sure, most certainly. Um, and
You always say the funniest things.
on my side, like I'll tell you, on my side, when it comes to what you were doing, I remember it was more like it was more like it was more like religious things I think you were doing at the time, or you were just getting out of very intense religious things, and you were trying to. I think that this was like a change period in your time, and like for me, right? I can tell you, for me, back then, 10 years ago, I was probably a carpenter back then, and I changed a few different careers, right? So I was a carpenter. I drove the train. I did a few different careers, yeah. But I was always like the programming was always something I always did, right? But it's when you don't have the opportunity. Sometimes people don't give you the opportunity, but eventually I had the opportunity to you know get into the tech industry, but I didn't really like the way I got into it. I got into it like very like payment systems and annoying customers and
You
and stuff.
came into tech in an unpleasant way
Yeah,
because you were involved in dealing with
well, just corporate
corporate
drama.
tech.
Yeah, and not really solving real, like, I guess you can say solving problems, but not solving, like, see, when you solve problems that are made from other, like made in the company, if the product really isn't that good, you're gonna get a lot of different
You're
issues that
talking about corporate level software where there isn't like the heart in it.
there isn't
There
heart,
isn't
right?
the
There's
heart.
no
There isn't
there's no
the
passion.
yeah.
Like there's just let's, find a fix. Let's patch it. Let's all patch. And these patches, they lead to more issues, as you can imagine. And like the company I worked for was a payment company, and it ran like most of like let's say all the hydro payments and electricity payments in Canada or the United States. So pretty big company, um, very big company. So old tech, but just you can see in the technology there was like no passion. Everything is like there's probably millions of lines of code at this point, but like everything is mishmash. Nothing is really like you know there's no teamwork, right? There's a lot of backstabbing in corporate, and I just getting introduced into that and working in that for many years
Yes.
was not good. But during that time, I was able to see other issues, right? So like when I was working at that payment company, we were obviously running a lot of different databases, like Oracle and to name a few. So many different databases, Redis, Snowflake, all these kind of different
Can we
technologies out
can
there.
we sorry, can we go a little deeper into that for
Yeah,
the
yeah, for sure.
beginners out there? It's a great story, but for like people who are new to databases, could you talk about the different types of databases?
Yeah, for sure. So like a database is like an information technology system, right? So when you have let's say a computer, you know, I'll give you a better example. Let's say you have like a hospital, right? Back then you would have to store a lot of these records, like let's say on a shelf, and somebody would have to go and look through the shelf and the indexes and find the records, right? It was all paper and shells and a lot of manual work, right? The database, what this allows for is for you to store the data inside of a computer and be able to query and retrieve that data based on let's say different predicates, right? So like you'll see like a select equals select where first name equals whatever it is, right? And find all the people with that first name or that phone number. Or so you can imagine there's like a schema that you can put together, like let's say a first name, a last name, a phone number, and this would be a schema. And then you would write data into that schema, and you can query that schema back. So that's kind of the idea of like a relational database. And you can join different tables, like that table with another table, and get different
And you're smiling, and you're smiling while talking about databases and information technology solutions. Yeah, interesting. And you're smiling because
well, it's well, I can explain, right? So when I saw those problems inside of the payment system using these databases, what I noticed is that they were pretty slow, right? So they were pretty slow. They were built on this older technology, right? So you can imagine when you're seeing these databases and in this payment company storing a lot of payments, storing a lot of customers, accounts, and doing all these things, you start to think, how does this black box work, right? Like, how does this really work? Like it's cool to understand and query it and insert data and retrieve data, but how does it work, right? Like
yes, yes,
that was kind of my question. And then over the time while I
yes.
was working there, I really I got into the weeds with it, writing. You can learn a programming language and kind of write the general basis of a database, like a key, like a storage system, so you can you know do something with just RAM in memory, just storing something in memory and getting it back. And then when the program shuts down, you lose everything, right? So there's different. You can store something in a file and then be able to get it back from the file. So like learning these different ideas from nothing and
Self-taught. You
self-taught. But
threw that in. You are a
yeah,
hundred
so
percent. Alex Padula is 100% self-taught. He never took a course. You know how many courses I've taken in math, computer science, data science, web development, web design,
yeah.
making courses. I still don't know what I'm talking about. You taught yourself everything. How? When? How?
Well, yeah, that's an interesting question. So yeah, with the programming, I think it's interesting because I got a computer when I was young, and I was very curious about the computer, about how to, I understood the web, but back then really there was not. I mean, you were on the web and you would see stuff on the web, but really, when I went on the computer, I wanted to figure out how to download like Visual Basic. I remember when I was young, I was trying to download these kind of like IDEs to start programming the computer to do something that I wanted. So that's kind of how it started, right? We're getting the tools and writing these obscure, really interesting programs when I was younger. But over time, you expand, right? Like there was new languages, new frameworks that came out. I expanded from like Visual Basic to C to C++ to Java, then into web, which was like back then was Ruby and Ruby on Rails, and then into databases, mixing the web and the storage system. So MySQL, and we'll talk about that, which is pretty interesting because like now I'm building the storage engine for MariaDB, which is from the creator of MySQL, right? So like, life takes you on crazy things, but yeah, yeah, just you get so curious. You know, it's really good to like keep
Curious.
that curiosity when you're a child. Like when you're a child, you're so curious. You're curious to the point of destruction, and as you mature, you seem to lose that curiosity. But
Curious to
keeping
the point of destruction. It's funny you say that. Yeah, I have a 2-year-old who's like comes downstairs and I like have my nicely packaged like song tiles and he's just like, "Oh, throw that over there and knock
yeah,
this over
yeah.
and beat up his father and take out the microphone out." And you're saying this is a creative destruction and a natural and a beautiful thing. We should
It is
nurture
beautiful.
this
It
destructive
is.
creativity.
Yeah, yeah. Like
Destructive.
yeah, I saw like I see kids do crazy things. Like they'll just like touch something not like you as an adult, you would never go to a soda fountain and like touch it and just see the the stuff come out. But a child is just like, what is that? How does that work?
What
Let me
is
click it.
and you're hinting that to be a great inventor, to think about a new type of database, to be like smart, you
Yeah,
have
to
to
think
be
to
like
well
you have
to
to
think
think
well
like a
to
child.
yeah, well it's kind of that. It's kind of but to really peak where nobody else peaks, you know. That's kind of what it is. And like when it comes to the databases, like when I worked for the payment company, there was like a, you know, I can explain, but it might go, you'll understand. I'll try to explain it in a simple way that everybody will understand. So in a normal database, you'll have like a one-way kind of operation. Like every kind of operation will have to wait in line, right? You know, like an operation will come for a write and a delete, and it'll have to wait in line with other operations,
The
right?
speed of the flow of data, the
Yeah, like
cycles of the
parallelism,
data.
right? Like you know how
Yeah.
things will come in a serialized fashion, or it's one step and then another step
You have
and then
to
another step.
each yeah, which means that each action in the computer's behavior,
It's chained, right? It comes,
it's like a
it has to
thing you
wait.
have to wait. It's like a
Yeah.
stop sign. It's a bunch of
Well,
stop signs.
yeah, it's like a stop sign, or like you know when you go to like let's say you do your license, and then there's a lot of people in the line, and then one person can go and take the service at a time.
Like a
That's
ticket,
kind of
like a ice
yeah,
cream, like a Baskin Robbins ice
yeah, and
cream
then it'll come in
ticket.
a
Now
sequence. Yeah,
serving 30, now
yeah,
serving,
exactly.
now episode 37 or something. Yeah,
Exactly.
I
And
get.
I thought that this was such a weird way to do it that I wanted to figure out a way that the computer can do it in parallel, right?
Have you
So,
figured this out?
yeah, yeah, yeah.
So you have invented a new type of database.
Yeah, yeah.
Why?
Using,
But when rappers produce a new song, discover a new form of music, there's a lot of yelling, taunting others, butts shaking in the background, and we have to plug our ears and swear words. You've also created great things. Where is the shaking of the butts?
with the music.
Or I'm saying like, where is you're smiling? You're smiling because of. Tell me more about this database you invented.
Well,
You're the
I'll tell you.
yeah.
I'll tell you something interesting. So when you can obviously parallelize something, right? So you can imagine if you have a counter, right, with many people serving that one line, the line will go faster, right? As opposed to just one concierge taking the people at one at a time. So that was kind of my idea, building. And here's the thing: I built something called the storage engine. So the storage engine actually powers the databases, right? So you know how you have a car, and the car can have all the technology, have every feature, but without the engine, it doesn't move, right? So
Yes.
yeah, so I wanted to design this like over the past few years, this engine that just doesn't slow down, right?
Wait a
So
second, wait a second. Just to unpack this, and I'm doing some research here. Storage engine is the foundational software component of a database management system
yeah,
responsible for the CRUD
yeah,
data. Okay, so anyone who doesn't know, CRUD is the creating, reading, updating, and deleting.
yeah,
CRUD. That's
yeah,
CRUD data. So this is sort of like a storage engine. It acts as the internal magic box that translates abstract database queries into actual physical operations on your disk or in memory. This is a memory. This is about disk space and memory. You
hmm
are a compression expert.
oh yeah, yeah. So well, I wouldn't consider myself an expert in anything really. I mean, so for me, like when it comes to the storage engines, you know, like it's interesting because now I have a lot of people, you know, ask me about the storage engines, and obviously, like it's kind of crazy nowadays where I see it going. But
What? No, you
what
can't just get. You can't slide that in.
I
Explain
I
yourself.
I, I, I oh well, it's wild because for me, I started designing and building these storage engines, and I built so many of them. I think 12 of them at this time over so many years, and it was just to understand how the bytes, like the byte you want to store something on disk and then retrieve it, like the different ways of doing that. And over this time of doing that, believe it, I never finished high school. I never went to university,
I know.
right?
I
And
know. That's what's
during
even
this,
scarier.
yeah, so during this time, I got invited to the University of Toronto by Niv Dayan, which is an assistant professor of computer science at Toronto, at University of Toronto, and he saw something in me. I don't know what it was, but he invited me to talk with a lot of like the PhD students and master students at UFT
Yes.
about storage systems, and I guess it was something about like doing something, you know, like when you're so passionate. I guess he just saw something and he to just invite a random guy. But I went in and I remember I was very scared to do it, and I went in and I had like the best time, and I got so inspired from everything that I already wrote some of TidesDB, and I was, if you know, TidesDB is like it's the storage engine that I was talking about, and then
Yes.
so I was discussing it there, and then from that point on, like I don't know what it is, but I just kept going with TidesDB and reading like papers and trying my best to understand them and implement them. And it just over this time, it's been crazy, man. But like I have like the biggest
You're not
companies.
bragging at all. You're allowed to
No, no, the
brag.
biggest people, the biggest companies following the work, which is pretty good, and running
You've
it and
invented a new database.
yeah,
So you have a completely new database with its own name, and you're
yeah,
the
and
founder and chief architect for the last 4 years and 2 months. You're the founder and chief architect of TidesDB and TidesDB Corp. It's your company.
yeah,
You run a, you are like Larry Ellison inventing Oracle. You have your own database
yeah, and you know
with your
what's
own
crazy?
style, with your own unshaven, flannelly style, with
Yeah,
comfortable
well,
chairs.
yeah, and this is not that comfy of a chair, I'll tell you. It's not that comfy. But I'll say something is, you know, for me, it's not about really like for me. I want people to find it useful, and that's why it's all open source. And I really just enjoy solving these problems, right?
Yeah.
And I'll tell you another interesting fact is like, you know, the only competitors that really TideCity has is Meta and Google. And to put myself in that position is crazy because it was just passion and drive that and curiosity to build something like that and follow it through and just consistency.
Yeah,
Um,
that's why I'm so curious and share what you don't brag. You don't like to brag about things.
no, but I because I don't look like so when it comes to the work. I let the work show for itself, and then other people tell me, like, I can see from other people that the work is good, and I can tell that I'm doing a good job, but I don't think I'm an expert in the field. Like,
You are
I
not.
don't.
You are very modest. What are
I think
people
I'm trying to
saying?
be.
People are saying you've solved a huge business challenge, a huge one. You
Yeah,
should
yeah.
be. You you are. You're not buying a fancy car. You're
No,
doing this as a charitable act.
yeah, yeah. And just because I enjoy it, and other people enjoy it, and they learn from the ideas that I put through, and with every new thing, there's obviously going to be other challenges to solve. So it's not like, oh, you do it and it's perfect right away. There's always other challenges. And then like currently, like TidesDB is going to be inside of MariaDB, and MariaDB is like powers 70% of the internet pretty much. Um, and yeah, to be the engine in that is a pretty big deal. So we're
So
working on that.
TidesDB is a high performance key value JSON. It started with
Oh,
JSON data
no,
structures.
no, key value. So I can explain that. So a key value is just obviously a key and a value, but the idea is you can use this key value to store a lot of different uh, forms of things, right? So like that key, then you can store any kind of binary data inside of that key, right? Like
You're not thinking of key value pairs.
it is a key value pair. Yeah,
It is a key
you store a
value
key
pair.
value pair,
So
but
you have.
in that key in that value, you can store anything. So you can store a JSON object, you can store a file, you can store anything inside of a key, right? But the key can also be like formatted different ways, like it's hard to explain, but you can imagine I can give you an example. I can give you an example. So I would have to write it or draw it. Well, I can give you an example. So, do you know what an index is?
Yeah.
Okay, so inside of a, like, let's say, like a phone book. The phone book will have like a lot of different indexes, and it'll be like A, B, C, D. You know what I mean?
Like a block of pages that is broken out cleanly.
Yeah. And we can say that, let's just say that there's a table. Let me draw it. Let me draw it. Let me draw it.
You can share
Let's.
your screen. Yeah, let's see your drawing of the. This is the architecture, the tree architecture. This is LSM tree architecture.
We'll show you. Let me see. Draw.
Buckle,
Sketch.
fasten your seatbelts.
Let me see here. Mm, Can you see it?
Yeah, yeah. Yes.
Okay, so let's make this thicker. So inside of I'm just gonna explain this key value thing because this is pretty important. So let's say I'm gonna do this with tables because tables is the most sensical thing that makes sense. So let's say you have like an account, right?
Yeah.
Sorry about my my terrible writing. Oh, it doesn't zoom out. Oh, that's okay. Let's say we have an account, and this is going to be a table, right? And in this account table, you can have like a number. Oh, a number, just an account number. And imagine this is a key, right? And we'll point to this like an account number. What else is an account? Let's say there's an account number. Then you can have a relation with the account. But let's say what else is part of an account? An address. Let's just say address. I'm sorry about my terrible writing.
This is the most interesting visual demo.
Okay, but what I'm trying to show you here is that this would be a T. So we're gonna say that table's T, and that this is K, right? So these two are gonna be K. So K for key, right? And T for table.
In any table, there are keys which are like placeholders. What is the number? What is the address? That's called a
Yeah,
key. That's called a
yeah,
key. A key is what is this box gonna? What's in going to go in this box?
yeah. So you can imagine that this is a schema, right? So like this is, let's say that this is we'll call this a table schema. So anytime we write data, we're gonna have to write an account number, and we're gonna have to obviously put an address in it, right? And that's gonna be the value inside of the key, right? So each key. So now I'm gonna give you. I'm just trying to. So what I'm trying to explain here is what a key value pair is in a database and how it kind of correlates, right? So when you and there's different orientations, right? So I'm gonna show you column orientation, so you can see the difference here, data orientation. So you
Hmm.
see over here,
So it's like a grid. It's a grid of key value pairs are really just another way to say a one line way of describing a table of data.
yeah. So you see the column here. You see column oriented. How this would be? Imagine the account number and then account address, and then there would be account numbers and account addresses. And for each row, this would be a record, a data record. This would be a full account or like a full user, let's say, right? So if I go back and let's say let's do this in a better way. We'll do it and use like let's say like a person. This, I think this is a better.
Okay, we're getting into these. A
So
better schema. You have a better
like a
schema.
yeah, even like a something with a like let's say I'm trying to, what's a modern day schema, like a
You're
social
teaching
network, like
like a university professor with a board and drawing. It's
well,
very.
so let's say like a oh, I can do this. Oh, so let's say we have a social network, right? Let's say we have this social network. This social network has to have obviously users, right? And then each user has to have posts. So you're gonna have this users. Let's say users table, right? And then you're gonna have, let's say, a post table, right? Like
Here
a
you're
very
showing
basic.
all the data that's stored in different categories.
Yeah. So basically, how does a user look? A user is gonna have a username. They're gonna have a password. They're gonna have a user ID, right? They're gonna have a user ID. Let's say username, password. Let's say email, right? So these are columns, right? These are columns in the database, right? So
Hmm.
this is the schema. So if we say oh, schema, where the hell did I go? Hmm, why is it different color? I don't know why. I guess it wants to be bigger, right?
I get the idea. I think it's.
I don't know why it's doing that. Ah,
But more about you. If you mind pausing the sharing, I get that. No, no, I want to. It's good to have a professor lesson. But tell me more about the university. What's going on at the university? The story. Less the.
well, the story. Oh, 1 second there. I lost my. Oh, how do I? Am I still sharing that screen? No.
No, no. But about your database, about the story. You want to talk about the data storage itself. No, I
Well,
would like to talk about that
maybe
also. But to the average
am I, am
person,
I,
They're
my
not
my
gonna.
main my main thing is that the key and the value, there's a lot of abstraction to it. I know I was getting it. I like to get in the weeds there. I don't know, but there's a lot of abstraction to the key value. And like when I went to the university, it was more about this data structure called the LSM tree. And the LSM tree is like a way to store these key value pairs, right? So like every database and every storage engine stores models data as key value pairs, right? You saw the data orientation, how like you can have the columns this way, you can have the columns this way, and this be a row, that be a row. There's different ways to orient the data in the storage engine, but the main thing is just key value pairs. Now,
LSM. Just to
the
just to
LS,
just to
the
explain it better, or just
the
to say it
LS,
also, the
the
log
LSM
structured merge
merged.
tree
Yeah,
design optimized for write heavy workloads with efficient read performance. You have gone into the read performance efficiency and you have cured the cancer.
yeah. So normally, if you know something about binary trees, so you probably know about a binary tree. If you study computer science, the binary tree is very basic, right? It has the keys, and you know it's just a basic. It's just a basic. Upside. You can imagine the roots of a tree, but it's upside down. Um, um, right?
Yeah.
The problem with these binary trees is that when they're fine probably in memory, and there's different types of binary trees. There's like the regular binary tree, there's the ABL tree, there's the B tree, B plus tree. The problem with these data structures is they're sorted, by the way. I should say that there's sorted data structures and there's non-sorted data structures. When you have a sorted data structure, it makes it easier to seek or do a range scan. So you can go like in a binary tree,
It's
you can
faster.
go,
It's
yeah,
faster.
you can go left or right in the tree, right? Like
It
and
has
kind of
two
you don't
legs, each child, and yeah, a binary tree is a tree data structure in which each node has at most two children. It's like yes or no switches. It's like it's a binary tree means for every point, kind of like a what's it like a plinko game, and you
yeah.
drop a chip down, and you
Well,
either go left or right. And
it's like, okay, what's the number I'm looking for? Five? Is five on the left of the tree or the right of the tree? Right? Left is probably the less numbers, and the right is the
yes,
higher numbers. So we're going to go right to the right of the tree, and it's going to be faster. So we do a lot less work in the binary tree. But and for sorted data, the binary tree is good, right? The problem is when you're writing data, right? So when you have to insert data, it obviously has to go and find a position in the tree to insert the data and then do the write, right? So it's not as fast. It has to go and do a lot more work. Now we're obviously trying to find ways to optimize this, and the way to optimize this is with something called the log structured merge tree. The LSM tree, what it does is it appends writes. So like on disk and like a hard disk or an SSD, they're very fast when you just append things. Like you know when you write something in a list, right? Like okay, I'm gonna do this and then this and then this and then it's just writing data sequentially, very fast, right? And this
that's
is
the challenge
immensely
here.
fast.
The challenge here to break it down. It's so complicated, the jargon. I'm just trying to help break it down. Well, to no, but there's so much wisdom here. Like you have the best. You outperform Rock's database
It's
across
just
almost all workloads by large margins. See this article for detail. How are you outside of the technology itself? Putting the technology aside and the mathematics aside and the combinatorial calculations aside, what is it? What's going on the commercial side? This is a company.
yeah. So like we have, we're trying to like, I have like a chief business officer, and he obviously is trying to get deals there and close contracts and uh, proof of POCs and getting LOIs and stuff like this. So it's yeah, it's a challenging thing to obviously sell something so new.
You're trying to sell it. You're trying to sell it in some way. The
Yeah,
whole
because
system.
well,
How do you
listen,
value such a system?
yeah, it's tough because for such new technology, people are obviously a lot more weary on it. So with time and putting it in enough people's faces, uh,
Marketing, you're trying to
yep,
market your technology,
yep,
and that is a challenge. Good tech, good ideas, technology ideas that are actually working. It's hard. It's
it is.
really hard. Why? Yeah, really good technology that's like futuristic. No one can even begin to understand it. And people tell you, I don't understand it, right?
Oh, yeah. Oh, yeah. Well, yeah. Well, I'll tell you, like on my side, I spent a very long time, like, people not understanding anything and telling me that I was going in the wrong direction. And then uh, more recently, uh, I'll talk. So like when you have the people that created RocksDB at Meta, this is Meta, WhatsApp, Facebook,
Yeah, rocks.
Instagram. When you have those people tell you and promote TidesDB, you made it. You
Rocks.
made a good technology.
RocksDB is a Facebook is made by Facebook, and it's in a similar world. It's also a complicated technology, and that
It is.
technology involves the LSM tree architecture, and it's a high performance, embeddable, persistent key value store developed by Meta, by Facebook. And it originally forked from Google's LevelDB, and it's optimized for fast storage environments. This is all about getting the most bang, most power out of like a mobile phone, isn't it? On apps. This is like an app phone storage
Well,
system.
this is like your feeds
Feeds.
on Facebook. This is like on Instagram, making things very fast. So you can imagine if you want to read the data you ingest very fast, the database has to be able to take that data in very fast, right? So
Every
you,
swipe. You're talking here in layman's terms. Dr. Padula here is describing to us muggles that when we flick our little thummy on the Instagram app and different pictures appear, what magician has sent such pictures? Where is them?
yeah,
How did the pictures get there? And how do they know? How do we know which pictures we should be requesting to ask for from a
well, yeah,
system that we're not even talking to? It has
yeah.
to be very fast, and it's like a machine. It's like an invention that no one can possibly understand,
Well,
right?
yeah, it's like when you swipe things on the phone, or when you're even scrolling, like when you're scrolling on the phone is doing and it's loading more data in each chunk, right? So this comes from a database, right? There's a lot of algorithms that go behind these things, right? So what I'm trying to say here is you know when you look at RocksDB, this has that limitation. Remember that there's that one line, and that one line can do one thing at a time. And then TidesDB is like, oh, let's open it up.
Tide, open up for the tide.
Let's fu- yeah, let's open up the tsunami.
Tsunami of data. That's
Yeah.
you. Wait. So the. Okay, I know a bit about this, and I'm getting better. RocksDB was released 14 years ago.
hmm
That was like its
And
first version. And
yeah,
then its
yeah.
stable release from like April 2025, like a year ago, whatever, is like 10.2. It's all C++. Everything's C++. You're big on C++. You're not a why? Why a low level language?
Well, so we're C. We do things in C. So yeah, C. I just really like C. It's simple. It's easy. I mean, obviously, if you look at the system now, it's probably not that simple as it was. Let's say like a couple years ago. Uh, just simply because like when you work on something every day, you obviously expand on it every day. You want to make it the best it can be every day. It's gonna get large, right? It's not
Only
gonna be
you.
small.
Only you. Only people like us. Only people like us are
Only
like that.
people that want
No,
to do it.
no, most people don't think like
Only
that.
only people that want to do it, right? So
But
as far
wait, could we unpack that? You can't slip in such wisdom there. You're all day. You are always thinking about the data. Your
Yeah.
brain is just filled with data.
You, you know what I have to say though is like I'm more like yeah. So for me, I'm like because data is like you can't lose it per se. I'm always thinking about different ways that it can be lost and like testing the different ways that it can be lost and writing the different tests and simulations on my side because
Yeah, yeah, yeah. Could you move
not
just a
knock on
little?
wood not
Sorry, Alex, we lost. Oh yeah, yeah. Sorry, we lost you there. You talk about this. Wait a second. So you're spending like 10 hours a day. You're just doing database design,
yeah,
and
yeah
you
and
love
just
it,
testing things yeah yeah
and you love it, and it's a paradise.
it is I enjoy it. I mean sometimes you'll like sometimes you get these weird bugs or whatever. Sometimes you just get lost sometimes in your own thinking. Like you're like, why did I
You're a
what
code perfectionist, like
yeah
me. Yeah, I get it. You're saying it more. You're vocalizing the emotional
it
layers here. You get entranced. Time drifts by. You are like playing God. You are in the machine. You have unlimited power. You are like a superhero.
yeah. And I mean when you win, like when you do things, it's like a win. And you find the bug and you correct it, it's like a win. Or when you see like performance gets better, it's like a win, you know. So there's
You like to work by yourself. You like to do research by yourself.
yeah sometimes I mean it's easier to well another piece is like when you're like sometimes if you see very large systems like very large systems you can tell it's not built by one person, right? But some systems they're very well designed. Like I'm not saying TideCP is well designed. I actually think it some parts are, maybe some parts need work, whatever. But you
But
know,
it's built by
when
one person. You're saying that things built by one person
it's easier to
have
understand.
one like DNA, one thought spread,
Well, you have one
one
vision.
one
It's
huge yeah, when one person, oh my god, I you're saying this I could never I never would have thought of saying it this way, but that's I so agree. When it's one person who does everything, designs everything, invents everything, all of it, then it's so pure because it's just one human person. It's just
yeah,
one person.
yeah, but it's easier to understand though as well. Like sometimes you'll see like I can give you an example, man. Like RocksDB.
Who's the author? Is it Druba?
Dude, RocksDB is there's it's what I mean. Like this is where we'll get into is RocksDB is very large, and it's I really don't
Yeah.
know who knows all of it inside of their head at this time, the way it is. And the problem with that is, I mean, I can't say that that's even a problem with like how a good AI is getting. Maybe people can really study something and get a good understanding of it, but it's not
Or
with
not.
everything.
Wait, no, 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 no. No one taught you anything. You're pure self taught. You're the opposite. No, 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 no. We should teach ourselves and we should build things ourselves, and then it will be good. Then it will be more fruitful. The opposite. Bad. It's you cannot no one really learns computer science in a classroom. That's the opposite. That's like trying to teach art by having people sit at desks and, color by number. No. Technology
Yeah,
is learned
so
by through its
so
mastery outside of the classroom. No one
yeah,
taught you anything.
no, no, no. But
How come you're
there's
not worth like 100 gazillion dollars?
maybe I am. I'll tell I'll tell you something interesting though. It's
Oy vey, I will shower next time and comb my hair in front of. Maybe
no
I
no.
am.
When I see like there's really smart people, man, out there that really um that know like there's very like computer science I would think is a very good thing to study, and there's very smart people out there that like I've met and that theoretically they're geniuses, man. They're very smart. Then there's like, I'm more of like a programmer. I like to solve problems with code, and the database is it to me it's just a very challenging and fun problem. Like it's like rocket science to me. Like a database cannot fail. Like when you send an e-transfer, when you send like a transaction to the bank, that can't fail, right? So, um,
But it does fail.
when though?
You're saying that it's such a crucial service, the storage of data and the way it's managed, that it cannot fail. It's like it's a mission that cannot fail. It's like
Can't fail.
war. It's like a war.
Yeah, it
It's like a
cannot fail.
battle.
So like that's how I look at it. And I come from a background that like I was a carpenter building the buildings in Toronto, starting from the foundation. So like the foundation of any software has to be strong, right?
You're
And I
big on the, the mastery at a carpenter level
yeah,
of
and just
technology
safety and like
systems.
having a good like foundation that is fault tolerant and like can't fail. And if it does fail, like what happens when it fails? Like can it recover itself? Like I'm really into these ideas. So
Yeah, yeah, yeah. Maybe we'll pause here. There's a lot to take in there. And that was so interesting, amazing. And I will pause here. Thank you.